A body constrained to move along z-axis of coordinate system is subjected to a constant force F given by F equals to minus I cap plus 2 j cap plus 3 k cap Newton, where I, j, k are unit vectors and along x-axis, y-axis and z-axis of the system respectively. What is the work done by this force in moving a body a distance of 4 meter along z-axis, 3 meter along y-axis? What is the total work done? So this is the force minus I cap plus 2 j cap plus 3 k cap Newton. This is the force equation for force. And first question is, we are moving the object in 4 meter along z axis. So what is the displacement vector? It is 4 k cap because it is z axis. Second question is 3 meter along y axis. So it will be 3 j cap. Okay. So we know work done is equals to F dot S, that is dot product or scalar product of force and displacement. So force minus I cap plus 2 j cap plus 3 k cap dot, what is the displacement we have to take? First one is 4 meter along z axis, so 4 k cap. So we are doing the dot product, and what is the answer we are getting? It is 12 joule. And second question, we should do it in the similar way, minus I cap plus 2 j cap plus 3 k cap, that force, and dot, what is the displacement? 3 j cap. So that is equals to 6 joule. Now we know force is the scalar, work done is a scalar quantity, force is a vector quantity, please. Work done is a scalar quantity. So what is the total work done? We can just add it, because this is 12 joule, and this displacement was k cap and this displacement was j cap. But anyhow the work done is scalar quantity, so it is not having any direction, so we can just add these two. So that is what is 18 joule is the total work done. A raindrop of radius 2 millimeter falls from a height of 500 meter above the ground. It falls with a decreasing acceleration due to viscous resistance of air until at half of its original height. It attains its maximum speed and moves with a uniform speed thereafter. What is the work done by the gravitational force on the drop in the first and second half of its journey? What is the work done by the resistive force in the entire journey if the speed of the drop on reaching ground is 10 meter per second? Take density of water as 10 cube kilogram per meter cube and gravity equals to 9.8 meter per second square. So here there is a raindrop which is starting to fall from a height 500 meter. So until it is covering half of the path, that is up to 250 meters, we can say, it is moving with a decreasing acceleration because of air resistance, and at this 250th meter it is gaining its maximum speed, and then it is going on with the same speed till reaching the ground. So this is what is told in the question, and the radius of the raindrop is 2 millimeter, and the height from where it starts falling is 500 meter above the ground. Now what we have to find is the work done by, first one is what is the work done by the gravitational force on the drop in the first and second half of the journey. So yes, please listen to these lines. Whether the raindrop falls with decreasing acceleration or with uniform speed, the work done by the gravitational force is same in its falling through the same distance. So we don't want the knowledge of the decreasing acceleration or increasing acceleration or uniform speed. The work done by the gravitational force is same, okay, in whatever its distance it is. So what is the gravitational force? It is mg. Generally it is mg. But we should know what is the mass of the raindrop, because we were given the value of radius of the raindrop. So from that we have to find what is the mass. So mass is density into volume. So what is the volume of sphere? It is 4 by 3 pi r cube into density. 4 by 3 pi r cube is 2 into 10 power minus 3 meter whole cube into, what is the density? It is 10 cube kilogram per meter cube. So the value of mass is 3.35 into 10 power minus 5 kilogram. So what is the gravitational force? It is mg. So it is 3.35 into 10 power minus 5 into 9.8 meter per second square. So the answer is 3.28 into 10 power minus 4 Newton. So the next question is, What is the work done by the gravitational force on the drop in its first and second half of the journey? So work done by the gravitational force in the second half of the journey. Sorry, second half of the journey or any half of the journey, first half or second half, the gravitational force, work done by the gravitational force is going to be the same, because it is m into g into h. Okay, so this mg is constant. What is the height we have to take? The first half height and the second half height. So if we are calculating for first half of the journey or second half of the journey, then consider the height, only the traveling height you have to consider. So here they are asking for each half, so the first half and second half. So any half we can take, so it is 250. Anyway, it is 250 only, so mg into h. The value of mg is already known. So from that we can write mgh, that is equals to 0.082 joule. So this is the work done by the gravitational force in each half of the journey or any half of the journey. This is the work done. So what will be the total work done? You have to add. So for reaching this half, so this half has work done, it is 0.082. Again for this half, work done by the gravitational force is 0.082 joule. So the total work done is 0.164 joule. Okay, so that is what is the total work done. Next question is, what is the work done by the resistive force in the entire journey if the speed of the drop on reaching the ground is 10 meter per second? So initially it was dropped and it is reaching the ground with 10 meter per second. That means it has acquired some kinetic energy. So what is the value of that kinetic energy? It is half mv square. So half, what is the mass of the raindrop? 3.35 into 10 power minus 5 kilogram into v square. So it is 10 meter per second, so 10 square. So we are getting the value of kinetic energy. So if you take the initial point when the drop was at some height, that is 500 meter, the initial kinetic energy was 0. Okay, there was no velocity at that time, so initial kinetic energy will be 0, while the final kinetic energy on reaching ground is this much. So what is the change in kinetic energy? Kinetic energy final minus kinetic energy initial, so that is this amount, same value. Okay, so now what does the work energy theorem says? The total work done, the net work done by all the conservative forces and non-conservative forces, that is equals to the change in kinetic energy. So from this delta k, that is change in kinetic energy, equals to work done by gravitational force plus work done by resistive force. So from that wr, that is why work done by resistive force is equals to change in kinetic energy minus work done by the gravitational force. So we are subtracting yeah, this from this, sorry, this one 0.164 joule and this one 1.675 and into 10 power minus 3, we are subtracting. What is the answer we get? It is minus 0.162 joule. So this is the work done by the resistive force.